Welcome to the Beer Taster's Notebook, the show dedicated to learning about beer. I'm Jonathan Thompson, advanced cicerone, beer judge, home brewer, and beer writer. Welcome back to the Beer Taster's Notebook, episode 13. Milling. So before we can mash the grains into sweet wort, we need to crush them. And right now, the grains intact are basically a protected asset, right? So the starches and other nutrients are kept safe within the fortifications of the husk, and we must break this apart. So into the mill we go. So essentially, first what we're doing is we need to crush the grain to expose the endosperm, but it's a bit more complicated than that. So first off, crush size does matter, and we'll get to that in a little bit, but so does keeping the husk intact. And so achieving target balance is key. So the more the grain is crushed, the more surface area the endosperm has, and therefore the better the extraction, and then the better the beer, of course. But the flip side is the more we degrade the husk, the less effective it acts as a filter bed, and the more potential polyphenol extraction we get, which contributes to both astringency and unwanted haze. And so in addition to this, the alurone layer, which houses a bunch of lipids and a host of enzymes, needs to also be split open. And so just on the grind size, infusion mashing tends to require a coarser grind than some of the more complex mashing regimes like decoction mash and step mashing. So let's talk mechanics here. So the two main types of mill are hammer mills and roller mills. And before milling, the malt needs to be cleaned to a certain degree, or I guess more accurately, it needs to be destoned and cleared of debris. So the destoner uses density like a float tank. Powerful rare earth magnets are also employed to pull out any metallic fragments, and we call this the malt dressing. So although most of this debris wouldn't necessarily be an issue in the finished product, as it would mostly get filtered out. So, I mean, if you end up with rocks in your mash tun or something, I mean, it's not going to end up in the beer. It's not ideal, but it's not the end of the world. But you certainly don't want rocks or metal going through your mill. So, I mean, in addition to any physical damage to the equipment, metal on metal can cause some sparks, and grain dust is pretty flammable. So that would be a bad scene. Okay, so the two types of mills. So a hammer mill uses impact, as the name might suggest. Essentially, there's a hopper into which goes the grain, and from there it enters the grinding chamber. And inside this chamber is a rotor attached to which are sort of steel plates or bars, and they're attached and arranged in a way that they can swing, hence the term hammer. And so this rotor spins at very high speed, so the material entering the chamber gets whacked over and over and over again by the plates until it reaches target size, after which it kind of falls through a screen at the bottom of the system into the discharge end of the system. This produces almost like a flour-like consistency, and it's really only employed when a mash filter is used. And so a mash filter is just that. It's like a series of filter plates, and the mash gets pushed through them instead of relying on the husks as a filter bed. They're pretty efficient with very high yield and much lower water wastage, and we can discuss them a little bit further when we get to mashing. And so a roller mill, which is the more common type, is a system whereby there's rollers working side by side, both rotating downward at the junction, and they crush the grains as the grains pass through the gap. The simplest system is a two-roller mill, which is exactly how it sounds. It's kind of like those pasta makers that you crank, which it's compress the dough into the sheets. And using a two-roller mill basically means that consistency in size is beyond essential of your malt. So if you can imagine the mill set to a specific size and 10% of the grain is smaller, well, then you get 10% that's not going to get crushed. So that's when 4 or 6 roller mills come into play. The 4-roller mill tend to be the most common outside of small breweries, like really small breweries and home brew operations. And in this case, the first set crushes, and then the crushed stuff gets discharged while the coarser residuals are then moved to the second set of rollers. And of course, 6-roller setups have, another set of rollers. So these rollers, by the way, can be smooth, or they can be knurled, which is becoming more common, also kind of known as serrated. So they're a little rough. And then when it comes to milling, there's sort of two major types of milling. So there's wet milling and dry milling. So dry milling is the most prevalent. It's kind of how it sounds. Actually, it's exactly how it sounds. Dry malt is crushed between rollers and screens, separate it, or hammers in certain cases. And it's definitely easier. It does produce pretty fine dust, which, as we mentioned, is highly flammable. So, welcome to the danger zone. Wet milling has the advantage of the kernel being mostly kind of squeezed out of the husk, which remains mostly intact. And in dry milling, sometimes the malt is conditioned, meaning it's got up to 2% water added and left for around 10 minutes and then milled. This is not the same thing as wet milling. In wet milling, the grain is soaked beforehand for a period of time, adding about 15 to 45% water. And so the output is more like a slurry than a meal. And this is pumped directly into the mash tun. So it needs to be crushed. I mean, you can't crush it and leave it sitting around. It gets crushed and then put right into the mash tun. It's already wet and starts mashing. So another advantage to wet milling is it reduces oxygen diffusion. It actually reduces lipoxygenase activity as well, which means that you get better stability. And so lipoxygenase is an enzyme that oxidizes linoleic acid in the mash. And so this will lead to elevated levels of trans-2-nonanol, which is that cardboard, wet paper taste that you really don't want. It's an oxidative product, but you can accelerate that by having excessive lipoxygenase activity. So obviously we can see why limiting this would be ideal. So along with wet milling, we do get an increase in protein extraction, along with increased extraction of beta-glucans, lipids, and polyphenols. Most of the particulate stays behind, of course, but it can still leach in. So despite the higher extract, which means more fermentables, the potential for polyphenol astringency and bitterness does exist. Obviously, this is mostly academic because systems of this caliber can be optimized for extraction. So adjuncts with no husk like corn or rice can be wet milled too. So with dry milling, we don't want to exceed, actually I shouldn't say that. We're looking around 10% flour, definitely not over 20%. It's very difficult to do that without a stuck mash. But with wet milling, we can get up to 70% flour and less than 10% coarse material, and the residual being sort of a fine slurry or grits, which means increased extraction, which I think you can sort of see is the theme here. So another advantage to wet milling, as I think I mentioned, is no dust, and therefore limited explosions in the brew house or in the mill. Okay, so why does grind size matter? Well, the more surface area, the better the extraction, the higher the fermentables, et cetera, et cetera. So we've been discussing finding the balance with the husk so we don't end up with issues, but let's go just a little bit deeper. So if the grind is too fine, we end up with a stuck mash. In other words, the wort can't flow through the filter bed. And we're not talking about mash filters. We're talking about a lauter tun or a mash tun here, right? And so too coarse a grind, and we're going to get very low efficiency. And then, too much flour, and we're going to get haze because it's going to come through. So grind size isn't particularly complicated, as you can see. Maybe we can get a little more into it if we do something on COA down the road. So the malt itself matters as well. The ease of which malt is able to be crushed is called friability. It's a measure of modification. The general definition of friability would be, the tendency to sort of crumble or break under pressure. So it guys is sort of the opposite of malleability. And so the only thing I'll just leave here is higher friability can lead to some runoff issues, but it's usually not really that much of an issue. And lower friability, of course, means a coarser grind because those grains aren't fracturing to the rate that we want. So I think that's really all I want to say on milling today, just as a general overview. So next we're going to start exploring the mash, which is going to get way more complicated. So look forward to much longer episodes. And until next time, stay thirsty and stay curious.